In this video, I will be performing programming exercise number 6 from the end of chapter 13. This will be over creating linked lists or using linked lists in a solution. Number 6 reads like this: In an ancient land, the beautiful Princess Eve had many suitors. She decided on the following procedure to determine which suitor she would marry. First of all of the suitors would be lined up one after another and assign numbers. The first suitor would be number 1, the second number 2, and so on up to the last suitor, number n. Starting at the first suitor, she would then count 3 suitors down the line because of the 3 letters in her name, and the third suitor would be eliminated from winning her hand and removed from the line. Eve would then continue, counting 3 more suitors and eliminate every third suitor. When she reached the end of the line, she would continue counting from the beginning. For example, if there were 6 suitors, if you can see in the text there, number 1 would win. Write a program that creates a circular linked list of nodes to determine which position you would stand in to marry the princess if there are n suitors. A circular linked list is a list where the linked field of the last node in the list references the node that is the head of the list. Your program should simulate the elimination process by deleting the node that corresponds to the suitor that is eliminated for each step in the process. Consider the possibility that you may need to delete the head node in the list. Okay. So let's create a brand new dev project. And I'll call this last name, first initial. Let's do 13-6, and I'll call it linked lists. And then, yeah, that'll be good. Console. Okay, and let's create a folder for it. And I'll call it 13-6 linked lists. Okay. All right. And the description, I'll say that it's 13-6 programming exercise, linked lists, and I'll say this program determines where to stand in a line of suitors that are eliminated based on the number of letters in the princess's name. It works by creating a circular linked list and simulating the elimination process. Okay, so the only adjustment I'm going to make to this program, I'd rather the user type the name of the princess in. That way we don't have to use Eve, hardcode Eve. Maybe we want Princess Zelda. So we're gonna prompt the user for the princess's name as well as the number of suitors. We'll need IOStream, and then because I'm making that one change, let's go ahead and include the string class so we can get the length of the string of the princess's name. Okay. So up here at the top is, I'm just going to put the the class, or actually let's just use a struct. We haven't used a struct yet, and from chapter 10 we saw how to create a class. A struct is just a class without any functions, so it's just a collection of different data types or different variables. So I'm going to create a struct that I'm going to call a pseudonode. And the struct takes the same form as a class. It has the curly braces with a semicolon at the end of the curly brace. Keyword struct pseudonode. And it'll behave like a class. It just doesn't have a class with no functions in it. So could you just create a class with no functions? Yeah, you could do that, but this is the alternative. Everything is public, and you don't have to have the public private. So int position is going to be one of the variables inside the pseudonode. So these nodes, this linked list, is going to be a collection of these struct instances. You can consider them objects if you'd like. So they're object instances that contain a number, which is their position in line, and then they are going to contain a link to, or a pointer to, a pseudonode. So you've got this circular definition going on here, and I'll call it next. So it has, the struct contains a pointer to a struct. So it's pointing to this a kind of its own, and you'll end up with all these pseudonodes strung together, pointing to one another, so that they're linked. Okay, and if you also noticed, I believe we talked about this in my intro video. If you want to create a type def, and I'm going to call it pseudonode pointer, or SNPTR. So what I'm doing here is I'm eliminating the hassle of the asterisk, that having to put that asterisk and use it back and forth can be confusing. Adding it to see the value, or to get the value of the that's located at that pointer, get the actual object at that pointer, and then taking it away to see the storage location, or the address, the actual hexadecimal address. So by creating a type def, keyword type def, a pseudonode pointer, we're defining a pseudonode pointer as SNPTR. So that word right there, we're creating our own definition, our own keyword, so to speak. So now if I want to create a pseudonode, I can do it using this text, and I don't have to fuss with the asterisks. Okay? Alright, so I'm just going to handle everything in the main here, just to kind of save time. First, we need to create a storage location for the princess's name. So princess name, and then an int for the number of suitors. And we'll prompt the user for that information. What is the lovely princess's first name? So maybe it's Eve, maybe it's Zelda, maybe it's Princess Toadstool. Read that in. Then we will ask the user how many suitors are in line. Enter the number of suitors. So in order to create a circular linked list, well, we can do that in a for loop, but we need to create the first one, and then we can have a for loop that generates the rest of them based off of that first one. So I need some pointers, and just to keep all of this stuff kind of together, I'm going to create my pointer definitions here. So I'm going to say um, pointer definitions, so SNPTR. I'm going to create 3 pointers, a current pointer, and then a tail pointer. Actually, I'll save the third one for later. For creating the circular linked list, we really only need 2. The current is going to keep track of which one we're on, and then actually the current will keep track of the first one as we create the circular linked list, and then the tail will keep track of the one we just created at the end. Okay, so I've got those 2 pointers, and they point to a instance of a suitor node. So I'm going to create the first node, doing it this way: current, which is a pointer. I'm going to have it point to a new suitor node. So I'm creating an instance, an unnamed instance. This is a dynamic variable that we looked at in our examples in that pointers video that I posted for you. So this is an unnamed variable instance. All we have is a pointer that points to where it's at. Other than that, we don't have a name for it in our code. We have a name for the pointer that points to it. So that current points to this new suitor node, and if you looked at the in the text, there is a shortcut for using the asterisk and trying to get one of the member variables out of a struct or a class that a pointer points to, and it's the arrow. So it's a combination of the dash or the minus symbol and then greater than. So that arrow, if I do this, current arrow position, that's going to get the position variable inside the new suitor node that current points to. See, it's pointing. And then I can set that value. I'm going to set it equal to 1. And then I'm going to set the next, which is a pointer. This is the pointer inside the struct instance. And I'm going to set that equal to current. So what that does is that makes the node point to itself. It's pointing to the same thing that current's pointing to, which is it. So that creates that circular linked list right off the bat. It's pointing to itself. And then I'm going to have one more pointer here, tail, and I'm going to set it equal to, so the pointer itself I'm going to set equal to current. So I've got tail and current and the pointer inside the node all pointing to this one node, the only node I have. Now I'll create the rest of the nodes. For int n equal 1, I'm going to start at 1 and go to n less than the number of suitors, n plus plus. Okay, so I'm starting at 1. You might think, well, that's not going to create all the nodes. Well, we already have one node. Here's the first node, so now we just need to go 1 to less than the total number. Okay, so this is how we're going to create the rest of them. We're going to start by creating a temp pointer, and we're going to set it equal to a new suitor node. Okay, then we're going to populate the information inside that new suitor node we just created that temp points to. We'll set its position equal to n plus 1. And I suppose you could go from 0 to less than n suitor plus 1, or actually I guess you could start at 2 here and then go to less than or equal to. That way you wouldn't have to add here, but still you'd either add 1 here or less than or equal to there, and start at 2, of course. Okay, so then temp next, the pointer inside this new node, we're going to have it point to what tail is currently pointing to. So that's why we needed that tail. That's going to move down the line, and that's what we're going to do next is redirect tail and redirect what tail points to. And you have to do it in this particular order. Anytime you're inserting a node into a linked list, you want to create the node, have that node point to the end of the list, or the one after it, which in this case is just circling back to the first one, and then you want to have the one before this one redirect it to point to it now. So that's inserted into the list, and you can see that maybe that little graphic there from our PowerPoint set. I'll throw that up here, right there. Okay, so then tail next. Now we're going to redirect tail next and have it point to the same node temp points to, this new node we just created. And then now we can redirect tail and say, okay, well, now this new one is the tail. So tail points to, tail points to temp. Okay, so it's confusing to think, well, when do I use the arrow? When do I use the equal sign? When you're setting a pointer equal, you want it to point to something else, and you have that pointer as just a named variable, then you just set them equal. But when we're using the arrow, that's getting the pointer inside, that's getting something inside of the struct. So there is a pointer in the struct, so that gets the pointer that temp that the node that temp points to, a little bit confusing there. And then here, this gets the pointer inside whatever node tail points to. And here we're setting it to equal to something else. Okay, so that should create all of our nodes. And again, I'm just going to continue on in this program. And now I'm going to process the suitors. And I could break some of this stuff out into separate functions, but we're just trying to solve this pretty specific problem here, and saving a little bit of time. Alright, so how do we process the suitors then? Well, we need a loop, of course, and I choose a while loop. I want this to delete nodes while we still have nodes to delete. Well, how do we know when we're at the final node? Well, once that node links back to itself, remember how this first node, its pointer pointed to itself. Once we find the node, or once we've deleted all of them except for one, that last node will be pointing to itself. So that's what our criteria is going to be in our list here. While current next, so the pointer that the current node points to, while that is not equal to that node, the same node current points to. So as long as that pointer doesn't point to itself, then we want to continue to delete nodes. Okay, and then how do we need to count down the line. And counting down the line in an array, or well, I'm sorry, a linked list. Counting down the line in a linked list is a little more difficult than counting down the line in an array. In an array, you can just name whatever indexed variable you want to look at and directly look at it. Well, in a linked list, you have these pointers that are keeping your place in this data structure, and then you have to count down using them. So we're going to have a for loop here. So count down the line in the linked list based on the length of the princess's name. So I'm going to do for int, I'll use in again, equal 1, and I'm going to go to in less than string princess name dot length in plus plus. Okay, I need to create one final pointer now. I suppose we could reuse tail, but I'm going to not do that so it doesn't get so confusing. I'm going to create a new pointer to keep track of where I'm at in my linked list. Or I need to actually keep track of the previous pointer in the linked list. When you delete a node from a linked list and take a look at this graphic, you need to keep track of the one before it, and then the one you're on, the one you're trying to delete. And yeah, we could reuse these current and tail, I suppose. Yeah, let's go ahead and change my mind again. Let's go ahead and create another pointer. So back up here, I'm going to create SNPTR, and I'll just call it previous. You can reuse these, I suppose, if you would like to. I think out of clarity, I will go ahead and use a new pointer that I'll call previous. Okay, so I'm going to set previous, that pointer. I'm going to have it start by pointing at current. And remember back up here, we haven't reset current at all. It's still pointing to the very first pseudonode. So we kind of kept track of the beginning. I suppose we could have called it beginning. I called it current because it's going to be the current one here in this deletion process. Alright, so I'm going to set previous equal to current. So now previous and previous and current are both pointing to the very first suitor node, and tail is going to be pointing to the very last node in the list. And I'm going to set current equal to current next. So what that will do is then with the current one is now going to be the next one down the line, which is the one that the current node, the node that current points to, it's pointing to the next one down the line. So that gets the next one, and so now we move that current pointer. So these pointers are just, we're going to move them down pointing to the different nodes in the list. Now that current points to the next one down the line. So this for loop will go less than the length, and it should end up on if the princess's name is Zelda, it should end up on the 5th one, right? If the name is Zelda, that's 5, so 1, and it goes to less than 5, so current, the first time through, current will point to 2, and then 3, and then 4, and then 5. So the loop goes 4 times, but since we started on 1, and in the first time through we go ahead and move current to 2, then the second time through we move current to 3. So that will end up pointing to current. Now after this for loop is done, current is pointing to the one we want to eliminate. And I'll take a look at the graphic, maybe that'll make some sense there for you. Now we just need to go ahead and eliminate that node that current points to. So in order to do that, I'm going to set previous next. So what we're doing is we're just rerouting the previous one around the current one with the one we want to delete. So it's the previous next, and it's no longer going to be what current points to. It's going to be, or I'm sorry, the node that the current pointer points to. It's going to be the node that that is being pointed to by the node that current points to. I know that sounds confusing, but take a look at the graphic. So current is a pointer. It's pointing to the one we're deleting. And the one we're deleting here, it has a node in it, remember. It has its own node pointer. It's pointing to the next one down the line. So that's the rerouting here. We're setting previous next, what it points to be pointing to the one that current next points to. Okay, so we've cut that current, the node that current points to, we've cut it out of the list. And now we're just going to delete it. Delete current. And then now we just need to move the pointer, the current pointer, have it point to previous next, which is the next one down the line. Okay, and that will eliminate all the nodes. That while loop will keep going. Since we're setting previous next to point to the one that current next points to. When we get down to 2, if you think about it, we have two nodes. One points to the next one, and that next one points back to the first one. When we delete that next one, we reroute the previous one before it to point to whatever it pointed to, which was that previous one. So then that's when we'll end up with a one single node that points to itself. The pointer in it, this pointer in it, points to itself, and that's when this while loop will end. And then that's when we can tell the user to win the princess's hand, you should stand in position and I'm just going to wrap over here so you can see it. Current position. So the one that current is sitting on, that's our winning suitor. Put an inline in there. Do we need inlines up here maybe? And we got inners there, so that should be good. Okay, let's run this thing. Go ahead and save it. Do I have any errors? Okay. What is the lovely princess's first name? We're going to type in Zelda here. Enter the number of suitors. I'm going to go with 16 to start with. To win the princess's hand, you should stand in position 6. And if you run through that, that should be correct. Let's use the example that the book used so that we can convince ourselves we did it right. The example they had was 6 suitors and then a 3-letter name. So we'll type in Eve, and then 6 suitors should stand in position 1. There you have it. Okay, so a lot was going on here. We had an opportunity to use several new things here: the struct, the typedef, and then the pointers, and using the arrow operator. Now I will tell you this: you will not have to use typedef or pointers on our final exam. From here on out, we only have one more chapter, chapter 14, where we will look at recursion, and then after that you'll be working on your personal projects. After we're done with the personal projects, then we will review for the exam, and like I said, the final exam, I'm not going to require that you know how to use pointers. If you want to use pointers in the solution, there's an opportunity to, but you won't necessarily have to. But you will need to use a class in the final exam. That's very important, object-oriented programming. So classes, or a struct is again just a class without functions. Those you will be responsible for. But typedef and pointers you will not, just so you know. And that's why I did these guided with you, and I'm not having you do these do a problem involving pointers or dynamic variables or linked lists on your own, because like I said, you won't see that in the final exam. So happy programming, know yourself.